Morning students. Today we are going to discuss toppers JEE NEET Foundation 8th class thermal properties of matter. So in the 8th class we have thermal properties, the solids expansion, liquids expansion and gaseous expansion. Solids expansion in previous classes you learnt, but in this session you are going to learn about liquids expansion, some conceptual understanding questions. The first question, the liquids are associated with the which type of expansion? The liquids are associated with the volumetric expansion. The volumetric expansion is the correct answer. See, the remaining options are wrong. So the second question, with the increase in the temperature, so there is a thrust on the body of the liquid decreases. The thrust on the body of the liquid decreases and apparent weight of the body also decreases. Thrust is so increases. That's why option both A and B, that is C, is correct. So coming to the next question, when the liquid in a vessel is heated, the level continuously raises. So in the liquids, actually whenever you heated the liquid, initially there is a container will gets heated. Initially the container gets heated, then later the liquids gets heated. So now if you take the containers, for example if you take a liquid, so if you start heating, the container gets heated. Due to the container expansion, the liquid level decreases. This is the container expansion of the liquid. Then liquid starts heating, then this is the, so liquids real expansion. The real expansion, so this difference, whatever this difference is called apparent expansion. Apparent expansion is nothing but the real expansion minus container expansion. The real expansion minus container expansion. If you observe these values, gamma r is positive, gamma g is 0. All these are above are correct. All the above are correct here. So coming to the next question, that is the density of water is maximum at 4 degrees centigrade, but the given options 4 degrees is not there. That's why option D is correct. So the 0 degrees to 73 degrees, all these are there. See, coming to the fifth question, liquids having a coefficient of cubical expansion is filled in the container having a alpha. If it is heated, it overflows. Which of the following conditions are correct? When the liquid gets heated, overflows, the gamma value will be greater than 3 alpha. Gamma value will be greater than 3 alpha. The remaining options are wrong. The remaining options are wrong. So coming to the next question, see, that is single correct answer type questions. The liquid in the liquid having a coefficient of cubical expansion, so is filled in the container having a, so container expansion is alpha, is heating. So this is the same question. The sea animals are safe in the winter and cold countries. So due to the anomalous expansion of water, anomalous expansion, so there is a strange behavior of water we observe from 0 to 4 degrees. That is option D is the correct answer for this question. So coming to the next question, liquid is filled in a flask up to a certain point. When the flask is heated, the level of the liquid, so initially falls because of container expansion, liquid level decreases, then starts rising. So that's why option B is the correct answer. The remaining options are wrong. So coming to the next question, when water is heated from 0 to 10 degrees centigrade, here also if you observe similar, 0 to 4 degrees, the strange behavior of water will be there. Then after 4 to 10, that's why first decreases then increases. Option B will be the correct answer. The remaining options are wrong. So coming to the next, a beaker is completely filled with water at 4 degrees centigrade. It overflows. See, when see, water gets heated above 4 degrees centigrade, expansion takes place, gets heated. That's why option A is the correct answer. The remaining options are wrong. It is not cooled below 4 degrees and etc. So coming to the next, coefficient of real expansion. Here the question what it is given. See, the real expansion of the water is given. The real expansion of the water, it is 27 into 10 power minus 4. 27 into 10 power minus 4 per degree centigrade. The linear expansion, that is alpha, linear expansion is given 10 into 10 power minus 5. So per degree centigrade. If you know linear expansion, you can find out. So container expansion. Container expansion is equal to 3 alpha, that is 30 into 10 power minus 5. So that becomes 3 into 10 power minus 4 per degree centigrade. So once if you know the real expansion and container expansion, you can find apparent expansion. Apparent expansion is equal to real expansion minus container expansion. So that means 27 minus 3, that is 24 into 10 power minus 4. So in the given options, so 24 into 10 power minus 4, it can be written as 2.4 into 10 power minus 3. So that is option D will be the correct answer. Option D will be the correct answer. So the next question, if the apparent change in the volume of the liquid is 100 degrees centigrade, so raises by 4%. 4% if it is raises, what will be the coefficient of apparent expansion? See, coefficient of apparent expansion is nothing but the same. It is change in volume per original volume per degree raise in temperature. So coefficient of apparent expansion is nothing but change in volume per original volume into change in temperature. So that 4% is delta V upon V. 4% means 4 by 100. Delta T is 100. That becomes 4 into 10 power minus 4 per degree centigrade. So this is about apparent expansion. If you observe the values, option B will be the 4 into 10 power minus 4. Option B will be the correct. The remaining options are wrong. 8 into 10 power, 16 into 10 power. These are the wrong answers. Coming to the next question. This is a simple solution. Increase in volume per original volume per degree raise in temperature. 12th question. A glass bulb volume 200 cc is filled with the liquid at 0 degree centigrade. The temperature of the system is raised to 100 degree centigrade. Alpha is given. If you try to find out how much volume is expelled, it means actually if you take here the alpha, if you know, alpha is 9 into 10 power minus 6. Alpha is 9 into 10 power minus 6, then you can find out gamma. Gamma is equal to, gamma G is equal to 3 alpha, that becomes 27 into 10 power minus 4 per degree centigrade. So now the real expansion is given. The real expansion is how much? 1.8 into 10 power minus 4. 1.8 into 10 power minus 4. So it is 10 power minus 6, 3 alpha. Now if you try to find out the gamma A is nothing but real expansion minus apparent container expansion. So real expansion is 1.8 minus 0.27 into 10 power minus 4 you can write, because 27 into 10 power minus 6 can be converted. So 1.8 minus 0.7, that becomes 1.53 into 10 power minus 4 per degree centigrade. So this is apparent expansion. Once if you got apparent expansion, the volume of liquid expelled. So volume of liquid expelled is nothing but change in volume per original volume per degree raise in temperature is equal to the apparent expansion, that is 1.53 into 10 power minus 4. So now change in volume should be find out. Liquid expelled. Original volume is given 200. So change in temperature is 100 to 0, 0 to 100. 100 it is the change in temperature. That becomes, so if you simplify this, it is actually 1.53 into 10 power minus 4. Now delta V becomes, this 4 zeros get cancelled. Delta V is equal to 3.06, that is 1.53 into 2, that is 3.06 cc. So that is the option B is the correct answer. Option B will be the correct answer for this case. See, coming to the next question, this is the simple explanation. So there are some small mistakes are there. Here gamma A should be there, here gamma R, and this is okay. So 3 alpha. So here delta should be there, here delta. So anyway, just I explained in the previous slide. So that is next question. When the specific gravity bottle is heated from T1 to T2 degrees centigrade, so the x grams of the liquid is expelled, m grams of the liquid remains in the bottle. So the coefficient of real expansion, is nothing but, see the formula for the coefficient of real expansion. See, the real expansion is equal to, so apparent expansion plus, so 3 alpha you can write, that is container expansion. So apparent expansion is nothing but the mass of liquid expelled upon original mass into change in temperature plus 3 alpha. So from this you can get here the options. If you observe, see the 4 options, option B will be matching to this, x by m into T2 minus T1 plus 3 alpha. 3 alpha here, this is the container expansion. So this will be the real expansion. So sorry, apparent expansion. From this you will get the coefficient of real expansion. So option B will be the correct. The remaining A, C, D are wrong answers. See, coming to the next question, this is the simple explanation. So a glass bulb of volume 250 cc, there is, which is completely filled with the mercury at 20 degrees centigrade. So the temperature of the system is raised to 110 degrees centigrade. The coefficient of linear expansion is given. See, coefficient of linear expansion alpha. See, alpha value is given, that is 9 into 10 power 6. 9 into 10 power minus 6 per degree centigrade. If you know alpha, you can find out gamma G. Gamma G is equal to 3 alpha. So that is 27 into 10 power minus 6 per degree centigrade. So this can be written as 0.27 into 10 power minus 6. Similar to the previous problem. The absolute expansion, here absolute expansion is given. Absolute expansion or real expansion, both are same. So the real expansion is equal to 1.8 into 10 power minus 4. So now try to find here apparent expansion. Apparent expansion is equal to real expansion minus container expansion. That becomes 1.8 minus 0.27. So into 10 power minus 4. So once if you got apparent expansion, you can find the delta V. Okay, so that is similar to the previous problem. Delta V upon V into delta T. So now here 1.53 you are going to get. The volume which is given 250 cc. 250 cc should be multiplied here. So delta V upon 250 into change in temperature. The change in temperature is, okay, initially 20 degrees, 110 degrees. 110 minus 20. 110 minus 20, that is equal to 1.53. If you calculate this, so delta V equal to 250 into, so 90 into 153, 1.53. So the calculations you are going to get here. So that is only 3.4425 cc you are going to get. So that is the correct answer. So 3.44 cc. Option A will be the correct answer. Option A will be the correct answer. This is about question number 14. So question number 15. A weight of thermometer contains 0.1021 kg of mercury. So now weights are given. When it is heated, then the height, see again this is weight of the, okay, so temperature, the mass is 2.1 grams overflows. See, 2.1 grams of mass which is overflows from that, okay, so container. So if the coefficient of apparent expansion of the mercury is given, and so the temperature is, what will be the temperature? In this problem, so we have to find temperature. So how much mass of liquid expelled from the thermometer? So we have to find the temperature. To find the temperature, the same formula here, gamma A equal to, okay, so Instead of volumes it is given kgs. So that we have to take here 2.1 grams and 1021 kgs. It means 1.021. If you try to find out here 0.0021 upon 0.1, so the mass of liquid which is expelled from that, the mass of liquid which is expelled from that, it is 0.0021, and upon 0.1 is the mass of remaining liquid. So you are going to get here, so coefficient of apparent expansion, if you calculate this 140 degrees centigrade, you are going to get, that is the rise of temperature, the rise of temperature. So 140 means here option A will be the correct answer, the remaining options are wrong. Coming to the next question, a flask contains 100 cc of liquid at 10 degrees centigrade. When it is heated to 110 degrees centigrade, so the volume of the liquid appears to be 2 cc, then coefficient of real expansion. Similar model problem, alpha is given, so that is 11 into 10 power minus 6. Alpha, if you know alpha, you can find gamma. So gamma g is equal to, see, gamma g is equal to 3 alpha, that is here 11 is given, so 33 into 10 power minus 6 per degree centigrade. So that becomes 0.33. 0.33 into 10 power minus 4 degree per degree centigrade. You can write like that. Once if you got this, okay, so now the temperature increase in the volume of the liquid appears to be 2 cc. Increase in the volume, it is given 2 cc. So we have to find out gamma A. Gamma A equal to change in volume per original volume. Change in volume is 2 cc, per original volume is 100 into change in temperature, that is again 100. So that becomes, if you observe carefully, 2 into 10 power minus 4 per degree centigrade. This is gamma A value. So gamma A value you know, gamma G, then gamma R is equal to gamma A plus gamma G. Gamma A plus gamma G, that is 2 into 10 power minus 4 plus 0.33 into 10 power minus 4. So that becomes 2.33 into 10 power minus 4. 2.33 into 10 power minus 4 per degree centigrade. So that is option D will be the correct answer. Option D will be the correct answer. You can do like this. This is a simple way sum. So coming to the, see, the explanation is given here. This is gamma and gamma alpha you have to replace. Then you will get. So next, sinker weighs 55 grams. There is a sinker, 17th question. 55 grams in the air. 30 grams in the liquid which is at a temperature 0 degrees centigrade. The same sinker 35 grams will be there at 50 degrees centigrade. What is the coefficient of real expansion? This is also, so when temperature changes, the weight of the body also changes. So how to find real expansion? Here there is a loss of weight should be found out at a temperature of, so T1 degrees centigrade, the loss of weight is, that is, so 55 minus 30, 55 minus 30, that means here 55 minus 30 is 25 grams, and loss of weight at a temperature T2 is again 20 grams. So real expansion is nothing but m1 minus m2 upon initial mass, okay, so that is m2 minus m1, m2 minus m1 into change in temperature, 50 minus 0. So now if you calculate, that is 25 minus 20 upon 20 into 50. So the calculation which gives 5 into 10 power minus 3 per degree centigrade. So this is the explanation for the question number 17. Coming to the question number 18, the body weights. So here, see, the height of the liquid columns are given, not body weight, it is the height of the liquid columns. So at 0 degrees centigrade, at 100 degrees centigrade, the height of the liquid columns are given. These heights are, one is 0.64, another will be the 0.6. So at 0 degrees centigrade 0.6 will be there, at 100 degrees centigrade 0.624 will be there. The coefficient of linear expansion 8 into 10 power minus 6. apparent expansion should be find out. See, once if you know the heights of the liquid columns, you can find out the apparent expansion. So you can find the real expansion. Real expansion can be find out from the heights. So the real expansion is nothing but the change in the heights. The change in height is 0.624 minus 0.6 upon 0.6 into change in temperature is 100 degrees centigrade. So this which gives us real expansion. And anyway we have container expansion. The container expansion, it is the container expansion is how much it is? 8 into 10 power minus 6. So from this you will get container expansion. So then apparent expansion is nothing but the real expansion minus container expansion. If you calculate this, so you will get here, see the simple solution, the 0.624 minus 0.6 upon 0.6 into 100, that becomes 400 you are going to get. So that 400, see, into 10 power minus 6, that, see these are gamma R, gamma A, 400 minus 3, 376 into 10 power minus 6. So answer is 376 into 10 power minus 6. Option B will be the correct. The remaining options are wrong. This is about question number 18. See, coming to the question number 19. The 19th question is solid floats in a liquid. Okay, so at 20 degrees centigrade with 75% immersed in the liquid. When the same solid, if it is heated to 100 degrees centigrade, it will be floating 80%. Then find the coefficient of real expansion. Here the liquid is floating in the water with at certain temperatures. If you observe carefully, so when liquid is floating in the water of 75% at a temperature of 20 degrees centigrade, 80% at a temperature of 100 degrees centigrade. So to find out this, we have, see, there is a direct formula for the real expansions. So in terms of densities, if you observe, the densities, so coming, yeah, the density, if you take it as the real expansions, okay, so this is the density instead of 75% of its volume at 20 degrees centigrade. So that's why you have to take here, see, 75 by 100 into the rho 20 into g. Weight is equal to mass into gravity. Mass is nothing but, so you can write in terms of volume, VdG. Mass is nothing but volume into density. At 20 degrees centigrade, 75% of volume. At 80 degrees centigrade, 100 degrees centigrade, 80% of volume. 80 V by 100. If you try to find out, see, first equation and second equation, this is first and this is second. So 1 upon 2, if you do it, you will get here the rho 20 by rho 100. This is rho 20, density at 20 degrees by density at 100 equal to 80 by 75. But in terms of, so real expansion, so the rho 20 can be written as, rho 100 into 1 plus the real expansion into change in temperature. This formula you can use. Okay, see, rho T is equal to, see, rho T1 is equal to rho T2 into 1 plus, so gamma T2 minus T1. The same formula if you apply for rho 20, rho 100 into 1 plus gamma into 100 minus 20 upon rho 100. Now rho 100 get cancelled. You are going to get 1 plus gamma into 100 minus 20 is 80, that equal to 80 by 75. Simplify this, gamma into 80 equal to, so 80 minus 75, 80 upon 75 minus 1, that becomes 5 upon 75. So from this calculation, gamma equal to, okay, you are going to get 5 upon 75 into 80. So calculate this, you are going to get the value of 8.33 into 10 power minus 4 per degree centigrade. See, the gamma, see here value of gamma, the value of real expansion of the liquid you are going to get here 5 into, so that is 8.33 into 10 power minus 4. If you observe the options, that is 8.33 into 10 power minus 4. Option B will be the correct answer. Option B will be the correct answer. So in this way we can solve these problems very easily. Thank you very much. Thank you for watching this video.